name is Janusz and I will show you how to make map of a cave composed of 6 or 7 measurements. So we have these measurements here, we have software here. So let's start. So we have already calculated LiDAR odometry, so let's copy this data and then let's change the name. Let's say step 3. Okay, so in step 3 we have our session, so let's open second step. And in second step we just open the session. So we have a session here. It is loading, you will see that it is plenty of data. But don't worry, the result will be amazing, so you will like doing this mapping. Okay, so we have cave here, and what we do with this, it will be quite long movie, so I will show you that here we have to only apply in Leo segments editor, we have to apply only set those that satisfy acceptable angle. So we set all IMU readings that they are, let's say, horizontal. It will help us later on, we will use it. It's important that our cave will be horizontal aligned. So we just do it and just save, and we save it. So we have session, okay. And once we have session, we can go to another one. So we have another session, 253. So let's copy data, our session. Let's change name of the folder. S3. Step 3, let's open our second step. Let's load this session. I will repeat it 7 times, so you don't have to be so focused at this moment. We just repeat loading session. In step 2, applying IMU horizontal alignment observation equations, and saving the session. So we have second session. Okay, so we have second session. You can see 800 scans. It's a lot of mobile mapping data. Okay, so please be patient. Almost loaded. Okay, so we have this one, and let's do the same. So tools, Leo segments, set those to satisfy 5 degrees. So you can see that we have this nice IMU readings. Can you see that it is very nice aligned? And we can save session. Okay, so we have another one. Let's work on the third one. Okay, so what we do? We just copy the folder. We change to S3. We just open our second step. Reload our session. This is a little small, so it will be faster. So it is the third component of our model, third local map. Okay, loaded. You can see that we have another part of the cave, another tools, segments, set those that satisfy acceptable angle. It means that every time we place the system, the mobile mapping system on the ground, the IMU will be showing the gravity, and we can use it for inclination observation. So let's save session. Okay, and now let's work on the fourth. So we have fourth component, fourth part. Let's copy data. Change the folder name. Let's open the session. You can see that I'm doing these things again and again. Maybe it could be automated somehow. So please be advised, or always welcome new developers. I'll be very happy if more people they can work on this, so you can see if something is done in not good way in your opinion. Please improve it. I will be very happy. So we are loading. Take some time. So it is the fourth, another 3. Okay, it is loaded. So we have another part of the cave. We in Leo segments we set those that satisfy 5 degree. We save session, and we have fourth one. Fifth, let's work on the fifth one. Almost done, another 3. So let's copy our folder. I'm working already 7 minutes. I think in 20 minutes I can finish entire cave. Let's hope. So you can see that it is quite efficient, but it can be much faster if we have more automation. So we have S3. We have to load it in the second step. Open. So we are opening the fifth data. It is quite huge, 1100 scans. So it will take a while to load, don't worry. Okay, so now it is downsampling data. Almost done. Okay, so we have quite longer part. You can see plenty of interesting places. Okay, so tools, segments. We just click to find those that they are 5 degrees, and then we save session. So let's save, and then we can proceed. So let's go to another one, another 2 left, and we can continue. So let's copy folder. Let's change the name to S3. Let's load it in our software, step second. So we open the session. Let's load the session. Oh, this one is 1355 local scans. Each local scan is around 5 meters length of the trajectory. It contains roughly 2 million, I think, points. I don't remember exactly, but it is quite huge. 1300, it is quite huge. I think more than 1 or 2 hours of data collection. I'm not sure, but it is quite big. That is why loading is quite time consuming. So we are working already 10 minutes on it. I am very happy that we are approaching half of our calculations, that we can use it in step 3, you will see. So what we do, we always load the data and we apply IMU observations. In that sense, our Postgraph SLAM will be able to not only resolve or solve the relative poses, but also it will use IMU for inclination. So tools, segments, we set those that they have 5 degrees, so you can see that if you place on the ground, you have this IMU, so you have this mark here. So let's save our session. And once it is saved, we can close it. Last one. We are approaching to the middle of this movie. So you can see that we copy the folder. And once we copy it, we change the name. And once we change the name, okay, almost, we change the name to with suffix S3, and then we open second step and we open the session, and this dataset has 1178 local scans. It's quite big. Okay, so we are approaching half of this movie, 12 minutes. I'm so sorry for this long. I'm so sorry that we have plenty of data, but believe me, this is exciting since it can build plenty of nice, adventurous data. So this project is for also for people that would like to make caving. We have a lot of end users and they are quite happy. I'm working on it, and I am happy to facilitate our caves in best software I can create. But I'm not so good in that sense. The software is also not good, so please be advised to help me. But this software can do something at least. It can do this, which you can see. So it can load data. The data is loaded, and this software can do also apply IMU observation equations. So you can see that you can set to satisfy 5 degrees, and we can save, and we are in the middle of the movie. So we save, and we are happy people in the half of this journey. Okay, so we have data. We have data of 7 trials, 7 collections in cave. So, step 3. And in step 3, we will create a project. So, file, add session. So we add all sessions. So we have session in S3. So we add session, another one, add session, another one, second one. You can see that I am adding session that I prepared just before. So the third one, okay, and the third one, fourth one, fifth one, sixth one. And the last one. I hope my software will not crash. Okay, so we have this one, those sessions, and now it is worth to save the project. So we have project, let's say S3. So we have the project, and now we can, because we have all data, let's say set up, so we can load sessions. And the sessions will be loaded with amount of time that we spent for all of them. So first one is loaded, now it is downsampled, and we have to wait, I think, 3-5 minutes that all data will be loaded. So we have little time to check emails, maybe something interesting, or I can give you some insights about the project. What could be the insight? So the idea about this exercise is that we go to the cave, we collect data. Each time we turn on the device and we collect data, we can use lidar odometry for initial trajectory. Afterwards, each trajectory can be calculated with additional observations from, for example, georeferencing data like control points, ground control points, aerial laser scanning, and so on. And obviously we can add IMU data. So once you place device on the ground and you make it horizontal with some additional equipment, then you can use it for your, let's say, tilting and rolling of your map. You will see how it works. Okay. And the idea behind this is that once you apply observations, it will always work in the factor graph built upon those all sessions. So don't be worried, just add observation and then you are sure that it is working for you. I will show you after a moment how it works. I think we loaded already 4 of them. Almost done, almost done. So 7 sessions, 5 minutes loading. I think it could be improved somehow, but believe me or not, it is already fast. It's already fast. But if somebody watching this movie can make it faster, please be advised to help us to improve this software. So this is another trajectory, and I think it is, I don't know if it is last one or not. Let's check. So we have 256. So what we have, how many we have, I don't remember exact number. So we have another 3 we have to load. So please be patient. It's almost. We are almost there. We are almost there. Okay, the almost last one. Honestly, I could cut this movie, but I did not have opportunity to discuss a little, so please be patient. It is already 20 minutes that you listen to me watching this. I hope you enjoy. You can always skip, it is quite repetitive movie, so we repetitively applied IMU observations to each 7 scans, but my end users, they asked me about this movie, so please be patient. If you don't like this movie, just skip it and don't care about it. But this movie is for those who really want to use step 2 and step 3 to create a map of the cave. The map that it is composed of more than one, in this case 7 sessions. So please be patient, almost done. I think I need another 10 minutes to finalize it. I have only 10 minutes, maybe 15, so let's hope we can manage. Last one, 1178 of data. I hope everything will work, because sometimes things happen. If this crashed, I lost 20 minutes, but believe me or not, I would like to finalize this movie with success, so let's hope, because it is showing how it works. If you can reach such a in step 3 such loading, then I am very happy. Maybe I will show you that how much memory it contains. Where is it? Okay, so if we take this one, you will see that CPU is working almost 100%, and the memory, I am using 43 gigabytes. So you can see that you should have at least 64 gigabytes to be capable to work on such a data sets. If you have 32, I don't know, I don't think so that it is quite sufficient computer. Okay, but if you have 64, it should be sufficient. I have 128. I know RAM recently is quite expensive, but okay, so we have all together, and now you can see that we have not so much robust rendering. You can downsample point cloud and trajectory. So if you put this minus here on top, then it can be much faster. Sorry, plus. If you put plus, then you can see that it is quite fast afterwards, the rendering. So let's put everything together now. So we go one by one. So we will use Gizmo to move your part of the cave to a proper place. So you can see that if you are familiar with Lego bricks or something like this, then you can easily combine everything together. I hope it is here, or maybe it is here. It is rather like this. Oh, my bad. Okay, it is like this. So it is like this. So in that sense, I can go again, or I can now. If I have 2, I can make a tool, and I can I can use manual loop closure, and then I can add edge. So if I put it here and here by clicking Ctrl and middle mouse, and if I put one here, then you will see that I have this one. So I add edge here, and I will manipulate it by ICP. And you can see that I am adding edge, and it is already registered. So what I am doing now, I am doing edge. I am adding edge between green and orange one, and you can see that the edge is already registered. Obviously speaking, you can do it much more accurate afterwards, but for me now, because I don't want to lose much time, for me it is sufficient. Okay, so I have this one. We have this edge 0. So now let's collect edge. Let's add edge, another edge. So we have to put here 100, and then we have to add. We have to use Gizmo to align another one. So we are somewhere here. I hope I was not measuring this cave, so I don't know if I'm correct or not, but I think yes. Okay, if I use Control and middle mouse, I can change rotation place, so it is helpful. Okay, I am going here, and I am going like this, and like this. I don't know if you agree with me, if it is like this. If you like Lego bricks or you are very good in 3D, then you can agree with me or not that it is exactly place that matches. Okay, I think it is. So in that sense, I can work again with loop closure, and if I put Control and middle mouse and Shift and middle mouse, then and one here, then I can see two separate scans. So I add edge and then use ICP half meter, then 25 centimeters, then 20, and you can see I am adding only one edge between two scans. You can add more later on, but I am showing you roughly how to make it in half hour. Okay, so we have this one, and I am very okay with that. Very okay with that. So okay, so let's continue with another one. So we add here more zeros. It's very important to downsample visualization, because if not, you have problems. Okay, so let's make another one. Where is my scan? Where is my scan? Oh, there is scan. So let's take Gizmo and let's go find. Okay. So maybe it is like this, and maybe like this. Okay. So. Okay, and let's find like this. I don't know. Maybe it is here. I don't know. So let's put this one and let's find. This. Maybe it is like this. I don't know. Let's find the, yeah. I think it is something like this. You can see it is very nice game to find a proper initial transformation. So it looks okay. So I will add edge. Sorry for that. So in that sense, I can add this edge. Okay, we have it. No. Sorry, I have to repeat it. So I can use this one also to find a proper place. Maybe this one and this one. Okay, it looks quite okay to find the transformation. Okay, so I add edge. I will use ICP half meter. And then this one. Okay, and the edge is already very good. Okay, the next one. So let's put it more zeros. Tools, manual loop closure. You can see that I am going to another one. Let's find it. It is somewhere far away. Okay, here. So let's use Gizmo. And then let's find a way how to align it. So it is already like this, I believe. And this one. And up. I'm quite efficient already with that, so so for me it's not a big deal to work on it. So you can see that initial alignment is quite straightforward. Okay, so now I can use tools and manual closure, and then left shift and control to find, and then once you have these candidates, you just add edge and ICP. This movie is for more advanced people, more advanced end users in this software, so I do not go deep into details. I'm just showing you workflow that you can practice. For more detailed information, I advise you for other movies. And you can see that I am almost done. So I will add it here 100, then I will put it here like this, then the almost last one. So let's find it. Let's with Gizmo, let's go with yeah. Okay, so and this is quite tricky, I believe. This is like this, am I right? It's quite tricky. Okay. So it will be here. It will be here. Okay. I don't know if I am correct or not. Yes, I am correct. So this initial alignment is quite challenging, but it is quite okay. So you can see that initial alignment is quite okay. For those who does not have this 3D imagination, it will be quite tricky, but don't worry, it is very nice opportunity to practice 3D orientation. Okay, so now let's add some edge. Let's add some edge. The edge, let's say it will be here. So okay. And if we put 1, we will see this edge, and let's align this edge. So we add edge, and then half meter ICP, then 25 centimeter ICP, and then 0.1 ICP, and we have everything here well aligned. And the last one. So what we do? We put 100 here, and we mark last one. Let's find it. I think this one is in front, so we have to just put front one, and you can see this is in front. So let's change the place with control and middle mouse, so you can see that I am changing the rotation, and then if I apply Gizmo, then I can find the initial transformation, but give me a second. It is quite challenging for me because Gizmo is far away, but it is challenging, so it will be like this. It will be like this, okay. Some rotation, translation, and I think we are quite aligned. We are quite initially aligned. This is the last one. Okay, so let's make a tools and let's add edge. So let's make a closer look. So control and middle mouse, shift middle mouse, let's put 1 to see what we have, and add edge and align 25 centimeters, 10 centimeters, 10 centimeters, And that's all. So I have 100, and now it would be nice. It would be nice now to save project, because we have all entire system is already designed. So we save the results, and everything is saved, and we save the project. File, save project. So we have this project as free, okay, and now you will see that I will simply optimize here entire system, and after 100 iterations it should be somehow better aligned. We have not so much edges, but please, I hope it will not fail. Okay, it is already optimized. So let's find some things to optimize better. I can see that between purple and blue. So let's keep purple and blue, and let's simply add edge. Okay, so we have this one. So let's add edge. So we have this loop closure mode. Let's add one. Where is our... Okay, so we have purple and blue. So we have this one. We have this one and this one. Okay, so we have purple and blue. So we just add edge. We use Gizmo now because it is far away. So we use Gizmo. You can see, okay, almost done. So now we can use 50 centimeters, then 25 centimeters. Maybe again 50 centimeters, 25 centimeters. Okay, 10 centimeters. And you can see now that we add edge, and what we can do now, we can add 100, sorry, 1000, and we can back to our this one, to this view, and then we can put all together, and you can see that now I am applying let's say optimization, 100 iteration, and you will see that purple and blue supposed to converge, and it is converged. So we can continue with that. So let's find the biggest error again. So maybe between green and blue. Okay, so let's find green and blue. Okay, sorry, yeah, blue. This one, and you can see some misalignment. So we back to manual closure. Maybe this one and this one. So let's put one here, and then we have this one. I can see that it can overlap. So we add edge, and you can see that always I am adding edge, and I do not think about IMU anymore because it is already applied. So, oh wow, why it is not? Give me a second. I am so frustrated in that sense that. Okay. Maybe supposed to be here and here. Okay. Is it correct? Yeah. Okay, and then we can have half meter, then 25 centimeters, and then 0.1 meter. So you can see that I am minimizing errors by adding edge. Let's stop here. It is 40 minutes already. So let's agree together that we have fantastic model. So let's observe it. So we have 0, 0, 0. We can now back to our main tool, and we can optimize. So we can turn on everything. We can see more points. And then once we optimize, we should see that green one and blue one supposed to be in the same place. And it is in the same place. Okay, so you can add more and more edges to reduce your error, but you can see that everything is very good candidate to publish the results. So you can see also that your IMU is well working, so you can see that your map is quite good. So let's publish results to Cloud Compare. So we save the results, and you can see that the results are saved to the session. Can you see session to the poses of the session? So let's save again, and then save the project that we can open it again. So this is the project S3, and now I would like to tell you that we can publish this in Cloud Compare. So let's minimize this one. Let's back to our step 2. And now we can open session. Our session is here. So we have this. Let's see. We have session here. So we have this one. And we open S3 our session, and then we save it, we export it, because now, because we are saving results in step 3, so we can export last file to Cloud Compare in step 2. So you can see that now we can export file, save all marked scan as a global scan. So let's say all s3.laz. It is saving. So we can close it. Let's open another one. Second one, and we will finalize this by opening this in Cloud Compare, but only 2 sessions to give you a chance to practice this by your own. So, or maybe 3 sessions. So this is very nice exercise. Almost. Almost done. Okay, it is done. So it is another part. You can see that it is not in origin, so it is in the global coordinate system. So let's save all marked scans as a global scan. All s3.laz. Let's open those 2 parts in Cloud Compare once it is saved. So I will open Cloud Compare. And let's open S3. This is our first part. And this is our second part. S3, I hope it is already. Yes, it is. This is second one. And you can see that we can construct our long cave from this data. So I will change only colors to high intensity, and I will close the movie here. Okay, so we have very nice one. Let's change the color to high intensity. Let's change color to high intensity, high contrast, and you can see that the cave is very well reconstructed, and you can do this by your own. And I hope this movie is sufficient for you. I was in hurry. I would like to do it in half hour. I did it in 45 minutes. I hope you enjoyed this one. So thank you very much. See you soon.